target for today is that we are going to be working with word problems. So this says, I can use addition and subtraction within 100 to solve word problems. Have you been working on things like that?
Yes.
Okay, so read our target with me today. I can use addition and subtraction within 100 to solve word problems. Okay, so here's a word problem right here. Here's a story problem. What were you picturing as you read this story? The way you're not shouting out and you're showing me that you think you know. I want you to talk to your partner. What did you picture as you read this story?
I think that some people got their lunch and some didn't. I pictured cafeteria and some sat down and put their lunch and they brought them and sat down so you would get their lunch.
Come back to me. Let me read it out loud just one more time, okay? I can't remember if I read it out loud or not. There are many students, read it with me. There are many students eating lunch in the cafeteria. Some of the students brought their lunch from home. I heard some of you sharing that you were picturing kids in a cafeteria. Does anybody have a me too? I heard some of you saying that. I heard you have, what else are you picturing? What else did you picture? What did you picture?
I pictured that there were two classes and then some of them brought their lunch and some of them didn't.
Oh, you pictured that some of them brought their lunch and some of them didn't. How many students do you think are in the cafeteria?
25. 26.
Why do you think 25 or 26?
How about 38? 51.
Why are you picking a number like that?
Why?
What makes you pick 51?
10 equals 38.
I want everybody looking at me. What made you picture 51? Or what made you say 51?
I was thinking if there were 25 students and 26 students in one class and 25 in another.
Why do you think there's that amount of students though? 51 is kind of a big number.
I know, but they might have had a small school where they had to gather up like all kinds of different grades.
Was there a word in the story that made you think to choose a bigger number? Look at the story for just a second. Was there a word in the story? What word?
Many.
There are many students. Did you want to choose a bigger number because it said that?
Yes.
You want to know how many students there were?
54. Why it was close?
What changed just now?
Oh, it says there are 54 students eating lunch in the cafeteria.
Okay, but let me ask you a question. Is that many students or not very many students?
No. Many. That's many.
Okay, it's many students. How many students do you think brought their lunch from home? Think it in your brain. How many students do you think brought their lunch from home?
35. One.
Turn and tell what you think and say the word because.
4. I think it's 39. 4 from one class and then 3 from the other. I think 5. I agree with that.
Okay, come back to me. How many do you think brought their lunch from home? What do you think?
4.
Why do you think 4?
Because it has 4. It has 4 1. That's 54.
Oh, you think maybe just the 4 ones and the number 54 is how many brought their lunch? Why'd you pick such a small number?
Oh, because it said some.
Oh.
Some.
So do you think more students brought their lunch from home than 54 or less?
Because many.
Why is that?
Many is bigger than some.
Oh, you want to know how many brought?
And some is littler than 29. 29 is close.
29 of the students brought their lunch from home.
I said 29.
Okay. Now let me ask you a question. Were you? Okay, here's my question for you. This is gonna be a story problem.
Another one.
What do you think I
Another
might,
one.
you ready? What do you think I might ask you about this problem? Think in your brain for just a minute. I want you to have time to think. What do you think my question might be?
That's 29.
Not yet. I'll let you talk in just a minute. What do you think I might ask you? There are 54 students eating lunch in the cafeteria. 29 of the students brought their lunch from home.
Oh, what did it equal?
What am I gonna ask you?
What does it equal?
I want you to turn and talk about it. What do you think I might ask?
How many students brought their lunch?
Okay. Come back to me. What do you think I might ask? Someone raise your hand and share with me. What do you think I might ask you? What do you think? Oh, wait, let's be good listeners. Really good hold on one second. Really good mathematicians are really good listeners. That's good mathematical practice, okay? So I want you to look at her when she's talking. Okay? What do you think I'm gonna ask?
How many 54 and 29 students are eating in the cafeteria?
How many 54 and 29 students are eating in the cafeteria? So what do you think I need to do with those numbers?
Add them up
Why?
to get our number of the story problem.
So you think, are you wanting to find out how many students there are? Does anybody agree with that or disagree with that? You agree with her? Somebody disagreed. You disagree? Why do you disagree? Do you think we need to find out how many total students there are?
No.
You think no? Why do you think no?
Because there might not, because we all know 29 is less than 54. And we know there's 54 in all.
Oh, hold on. He brings up a different point. Everybody look at me. He's saying we already know how many students there are.
No, we don't. In all. 54, it says.
Look at the word problem and you decide for yourself.
82.
Do we already know how many students are in the cafeteria?
No. Yes. No. Yes, we know.
I want you right now. I want you to read it by yourself. Don't talk. Read it to yourself. Okay. I'm going to ask you a question. I don't want you to answer without thinking. Okay? I want you to think about what I'm saying. Do we already know how many students are in the cafeteria?
No.
Think about it. I want you to turn and talk. Go. You think we do know? How do you know that?
It just says we only have 54 students in the cafeteria.
Okay, come back to me.
Yes.
Do we know how many students are in the cafeteria?
Yes.
How many?
54.
Okay, so let me ask you a question. Earlier, a lot of you were saying that we needed to add the numbers to find out how many students were in the cafeteria. Is that correct?
No.
So what do you think I might want to know? I'm going to read you the problem again. There are 54 students eating lunch in the cafeteria. 29 of the students brought their lunch from home. What do you think I might ask? Think about it in your brain. What might I ask? Turn and talk about it. I'm going to ask you. What do you think?
I think you're going to ask us 29 minus 54.
Am I going to say, what is 29 minus 54? I want to know what question about the story am I going to ask? You said I'm not going to ask how many total students are there. But what might I want to know? What do you think?
I think you're wanting to know how many students did not bring their lunch.
That's what you said. That's what I really meant. Okay. Do you agree with that? How many students did not bring their lunch? Do you think I might ask you that?
Yes. I agree.
You ready to see it?
Yes. How many students did not bring their lunch from home? I got right. Me too.
Were y'all correct?
Yes.
Huh. Okay, so what I want to know is how many students did not bring their lunch from home? How can we figure that out? What do you think you're going to do? Think it in your brain. Don't say it out loud because we're going to work on it in small groups. What might you do if I want to know how many students did not bring their lunch?
500.
It had to take some thinking, didn't it? So, can you remember what the story was about? Let's go ahead and retell it in our own words before we dive in and start solving it. Do you remember what it was about? What was it? You want to get him started, and then maybe you can pick up with it. What do you remember?
That there were 54 students eating lunch in the cafeteria.
There was 54 students eating lunch in the cafeteria.
And some brought their lunch from home.
Oh, some of them brought them their lunch from home. Okay.
There were 24. No, 29. So 29.
Oh, so 29 of those students brought their lunch?
Yes.
Okay, what did I want to know?
How many people not brought their lunch from home?
How many students did
No.
bring their lunch? Alright, so I'm going to give you this. And here's the word problem. So I want you to think for just a minute. I want to know how many students did not bring their lunch from home. How do you go about solving this? I want you to think about it for just a minute. How do you think you might solve it? Maybe you have a plan? I'm going to give you some of these, and you are welcome to use them, okay? Use them if you need them. I want you to be able to show your work though. So whatever you do, I want you to go and draw a picture to show how you solved it. Can you do that for me? Okay. I want you to know, I want you to share with your partner. I want you two to be partners, and I want you three to be partners. I want you to share with your partner what your plan is going to be. What do you think you're going to do to solve it? Ready? Go.
Hold up, I have an idea, guys. Hold up, I have an idea. Know how we have 54? What do you, so I was thinking if we could do 54 minus 29.
Think you've got a plan? No, go ahead. Okay, you think you have a plan? Alright. I want you to go ahead and start solving it, okay? Okay, so I want to be able to go over with you what some of the students were talking about in this group. You heard a couple of the boys talking about how they were going to subtract to solve. They wanted to do 54 minus 29 to figure out how many students did not bring their lunch. So I have rewritten their student work only because it was really hard to see what they wrote in pencil. So one of the students did it on a number line. He subtracted 20 and then he subtracted 9 more. You can see that he broke up his 1s in 4 and 5. The next student used regrouping with base 10 drawings to solve. So they both got the correct answer, but they solved it two very different ways. So I thought that was really interesting. You're going to also see that some of the kids were struggling with this. I know that you could see that in the whole group lesson. They were struggling. This was the first time they had ever seen a numberless word problem, but I feel like it was a really productive struggle. So another thing that I did for some students was I did have to lower the number for a few of the students so that they could work through the comprehension part of the word problem, and the magnitude of number wasn't such a barrier for them. I only did that for a couple though, and that is my last resort because I want to see if they can productively struggle through this at the level that I originally gave them. What do you think you might need to do?
What know the answer.
Why are you going to add something to 29?
Because we know that we're going to add.
Okay, so the little girl that you just saw me having a conversation with, she used a counting on strategy. She started with 29, and then she knew she could just count on until she got to 54, and that would let her know how many students did not bring their lunch. So I was really impressed with her strategy. She was using a really efficient strategy, and here's the student work that she did. And at the end, she even was able to label what 29 represented, what 25 represented, and what 54 represented when she rewrote her equation. So that is something that you really want your students doing, is labeling each piece of the equation to show what it is representing.
So what is this missing number going to tell us?
It's going to tell us how many kids are eating lunch in the cafeteria.
Okay.
Like the kids that didn't bring their lunch.
So this represents kids that did not bring their lunch.
Okay, so the last little girl that you're going to see me talking to ended up using the part-whole strategy. In the beginning, she was wanting to actually add the two numbers because she didn't fully comprehend the problem. And then toward the end of the small group, she realized that she had a misconception and wanted to stay for the second group to be able to work through it correctly. So I was really, really proud of her for being so dedicated about working through this word problem. She actually ended up not drawing a picture. She just needed to use those concrete models to be able to comprehend the.
Okay, you ready? Okay. You said this was 54 students per grade, right? How could you represent, we were saying earlier, how could you represent that 21 of those students brought their lunch?
Okay, so here's what the little girl did. She started with 5 10s and 4 1s to represent 54. Then she realized that when she wanted to pull the 29 away to represent how many students brought their lunch, that she needed to decompose one of her 10s. So she regrouped the number from being 5 10s and 4 1s to being 4 10s and 14 1s. So here's a picture of what she did.
So in your picture, which part represents how many did not bring their lunch? Oh, how many is that? What is this though? Is this 2? Okay, so how many students did not bring their lunch?
After the little girl had regrouped her number, then she was able to pull 29 away to represent how many students brought their lunch. And you can see that I did that in the black. And then she was left with 24, which represent how many students did not bring their lunch. So then she realized that she had gotten the correct answer. After that, she had a great conversation with me about how she knew that 54 was the total, and she knew that a part of that represented how many students brought their lunch, and the other part represented how many students did not, and that was what she had to figure out. At the very end of the lesson, there was a student-led debrief. I always want students to lead that debrief rather than myself because I never want to say anything in a math lesson that a kid could have said. So the little girl actually led the debrief about the part-whole strategy that she used. I also let a few of the other students talk about their strategies of how they counted up or they counted back to figure out how many students did not bring their lunch. That student-led debrief is so important because kids learn so much from each other. They can learn more from each other than they can often learn from us. So don't ever leave that part out of the lesson. Okay, so as you saw at the beginning of this video, the kids were really struggling with comprehending this problem. They wanted to just grab the numbers out of habit and add the numbers. But then, as you see throughout the video, the kids started to productively struggle through this, and they started thinking about the story problem. I hope that this numberless word problem lesson was helpful for you. This is just a great way to help kids slow down and comprehend the story and make a plan before they jump in and solve it. I hope that you'll try implementing it in your classroom soon. This is something that you can do in any grade level. So it doesn't matter what grade you're in, whether you're in kindergarten or you're in 5th grade, numberless word problems are great for all kids. If you have any questions about how to get started, please contact me. I am happy to help in any way. I hope you all have a fabulous week.